Hello. Present video is for present the artificial vision to detect sharp objects. Well, right now we have the first, and it's the imaging capture. We need some kind of font or source or prime material to work, and in this case is the images or the pictures that we can capture. In this we have example with this diagram where we have a light source that always reflect in the scene. The scene could be different objects and environments, then let them that light reflect and get into a lens, and the lens can be the form these images or this capture, no? Because sometimes the lens is used for give a specific form or get a specific characteristics. That's the reason, because some lens the form the all the scene that is captured by the sensor that are the cell CCD or CCMOS, and it's a specific technology. But this sensor, the work of this sensor is transform that scene and the light and its logic to a digital way. So this can be processed by a computer, and we get an imaging plane. This imaging plane is it's literally the image that we have captured, and this um, is corrected by the software or hardware that we have, and many of the times and don't get that inverted position in vertical. The artificial vision, it's to try to emulate or simulate the vision of the human being, but even works better for some kind of works. In this case, we have an example that is focusing element, and we can see in the picture that this is a piece or a device from a car, because we can see in a little position the Ford logo. Replace the people that could be there just trying to find what is the problem, but this system detected and is processed by a hardware and a specific software. This optimizes the work and is more effective with the pass of the years, and with the pass of the advance of technology. We get better hardware with the GPU when was made the jump to the CPU to the GPU, and it's that. We have YOLO, and there is how it works in YOLO. And there are different versions of it. It's fast in video, and there are more than one ways to codify it. So we have the diagram of how it's working YOLO, and we have the different convolutional layers. If I'm not wrong, the original convolutional network for YOLO, the first iteration of YOLO, was Darknet 53 or 56, and this has been combined with other technologies and getting better, because how I said before, there are different versions of it. There are YOLO version 2, version 3, version 4, and even I know that there are version 5, but I'm not very sure on how it works in the version 5. And between this version, there are other versions that have a little improvements in the work. But here we have the how it works, or more specifically in a summary resumed form, because we have the image that is input to the algorithm, and this is gridded, and we have a class probability map. Then always pues is a map, or this could be the object that we can found and that we want to be found. So this generate 100 or 1,000 bounding boxes to the object that will be selected. And finally, these boxes are deleted to just keep that then working correctly, or that get the object that we desire and we want. Fast RNC, we have also how it works, but this is the last iteration of RECN, or it's not the last iteration, because Fast RNC have other iteration and have uh, other better versions, version 2.0, then we can work with kind of environment and have a lot of precision. This is one of things that could be improved and could be proud. YOLO, it's with the speed that they have. So faster is the precision that they have, because they generate the proposal regions then where could be the object that we want. So the characteristic maps is looking for that. We eliminate by the pooling the regions that have the least value, and in both algorithms we see we we set a value where we can say that yes or not if the object is there. So that is because we are using a supervised supervised training, and that's the reason because we give this value to these pictures. And the reason because we give that value is from how we can get it, the different pictures or the images. Right here, imagine dataset is one of the most easiest way to obtain these images. Then dataset is no more than a collection of 100,000 and maybe 100,000 pictures that could be used for these algorithms. From some examples of this dataset that are public and can be used for the people in the community and admire for that, it's Google dataset. Google Open Images, well, it's Google, it's so massive and have a lot of information. Between them is the images and visual genome. Then it's have a specific dataset with a specific or at least until where I can see, and then have a specific formats for the image or for the algorithms that need to be trained. These algorithms in the value assignation, we could tag these classes and make the area selection and give the different formats by a GUI, and we can develop through the different languages. Between that is Python, and we can use the libraries from PyQt for make that GUI. But we have this tool that could be and is so useful for tag all the classes and the pictures. Then it's called lab imag. Then do all the things that I have say. We can open the folder, we can select the image and tag the class. Just using the mouse, putting in one corner in the top and other in the down, and we have selected the area. We tag that area with the with the class and we want to be detected. In this case, we can see that there are person, so they are selection of the person, and they are the next image, the previous image, verify if the image is good, save with the name, a specific name, and the format that we could be using in the algorithm. This example have a Pascal bug, but this program or this tool have two the format for YOLO. The codifications, we can use Anaconda, Python, and TensorFlow. And this was the first idea in the presentation, because Anaconda is environment programming environment and have a lot of tools and a lot of gears and can use it for programming, and it's based in Python. The Python is so comfortable for because have that same, and it's open source, and the community is always asking and answering about the different problems that they have and different ways that they found, and it's free. No, and TensorFlow, it's some kind of the same because it's open source, and TensorFlow born, no, in if until I know, in Google. So we have two the tools from Google, and is Google Colab or Collaboration Lab. I I don't know. I'm not sure if that's the name, but Google Colab bring us something that TensorFlow and Anaconda can't, at least today. Then it's give us a hardware that it's more powerful, because Google bring us bring us a computer that have more power than maybe many of us can have in our houses. So the only thing that have collab it's for pay when you end with your test of free pass. But this could be useful when we need to keep time, no? When we gonna use money, spend money, but we're gonna keep time. And these are the references, and this will be all. Thanks.